All right, this is on imaginary units and complex numbers. So in the yellow box is the definition of an imaginary unit. Is defined by the little letter I. So I represents the square root of -1. When you see I squared, it equals -1. So I want to explain where I squared becomes. So when you split up I squared, you have a I times I. Then I'm going to replace those i's with the square root of -1 and the square root of -1. I'm going to combine those together into one radical, negative as one radical. And that's the square root of -1 all squared. So what happens is that square root and that squared undo each other and you're left with -1. All right, first example, we want to simplify the square root of -25. So we're going to separate it out as the square root of 25 times the square root of -1. Then the square root of 25 is a perfect square, so the square root of 25 is 5. And then the square root of -1 is our imaginary unit. So your final answer is 5i. Second example, 5i all squared represents 5i times 5i. Well, 5i times 5i is 25i squared. We're going to replace that I squared with -1 because I squared equals -1, and then multiply it. You get -25. Heading to the next yellow box is the definition for complex numbers. So when you see this form a plus bi, it's considered a complex number. The real piece is a, and the b is called the imaginary part. So if we look at these examples, here's a complex number. This is the real part, and this is the imaginary part. And you can see the other examples. All right. So when we add and subtract complex numbers, you want to add the real parts together and the imaginary parts together. If you're subtracting, you have to be very careful. You have to distribute the negative through and then combine real parts and imaginary parts. So here we go. First example, this is a complex number adding another complex number. So I'm going to go ahead and just drop the parentheses. Now I'm going to rearrange so I have my real parts together and then our imaginary parts together. Now we combine. Real parts, 5 plus 3 is 8. Imaginary parts combined together to give you positive 1i or I. In example B, we have a complex number and another complex number. Notice the operation between this is subtraction. So when we drop the parentheses, we have to distribute that subtraction sign through. So it's going to change those signs. We have 2 plus 6i, and then minus 12 plus I. Now I'm going to rearrange the terms, having my real pieces together, the 2 minus 12, and then my imaginary pieces next to each other. Now we combine the real pieces, -10, and the imaginary pieces, 7i. And what you'll get is a new complex number in standard form. Now we're going to go ahead and multiply. So when we multiply, we're going to distribute this complex number into both the real and the imaginary. So we have 7i times 2 plus 7i and negative 9i. 7i times 2 is 14i. 7i times negative 9i is negative 63i squared. Now we do need to simplify this farther by remembering the rule of this I squared. Remember, I squared equals negative 1. So we're going to replace that negative 63 is going to change that to a positive 63. So our final answer then is negative 63 turns that to a positive 63. And then we have 14i. You always want to put in standard form your real part first, then your imaginary part. That is considered standard form. Moving on to multiplying this complex number to the other complex number. You want to think of these as two binomials and you're FOILing them out. So we have 5 times 6, so that's your first. Then we go to outside. Then we go to inside. And then we go to last. The middle two terms combine together. They're alike. They're the imaginary pieces, imaginary parts, to give you negative 59i. Here is that I squared. It's going to change to negative 1. So we're going to get 30, changing that negative 28 to a positive 28, and then minus 59i. Combine our real pieces together. 58 minus 59i.